columns just for the invocations of the subroutines, because we have to take care of one invocation first, invoke clone 7 goes to x, then we take care of the other clone, 15 goes to x. Once we know the result of the first clone and the second clone, then we invoke add. Okay? In other words, we are only using 3 columns because 3 is the maximum of 2, 2, and 3. Are we doing okay with this? Sort of. Okay. Let me make sure we save this one. Any questions about return values? Are we ready to work on Fibonacci numbers?
Yeah, that's fine.
Okay, let's do it.
I watched numbers. I watched numbers when he talked about.
Oh.
Did a show on
Fibonacci numbers?
Yep.
Fibonacci numbers.
Fibonacci and numbers in.
Yeah, Wikipedia has a good introduction because I just want to show you the definition of Fibonacci numbers. F of n is f of n minus 1 plus f of n minus 2. What is already defined is f of 0 is 0, f of 1 is 1. Okay, let's just work out a few of these numbers by hand first, just to make sure that we know how to deal with it. So that means f of 3, because 3 is not 0, 3 is not 1, that means we have to use f of 2 plus f of 1. f of 2, okay, do it this way. f of 2, 2 is not 0, 2 is not 1, I have to use the recursive definition. So this is f of 1 plus f of 0. f of 1, by definition, is 1. f of 0, by definition, is 0. 1 plus 0 is 1, so f of 2 is 1. Is that okay? f of 1, by definition, is 1. This one is 1, this one is 1, so f of 3 is 2.
Where does the n minus 1 and n minus 2 come in?
Well, when n is not 0 and n is not 1, then you use this equation. If n is 10, then it becomes f of 9 plus f of 8. Okay, so let's just look at the sequence here. f of 0, f of 1, f of 2, this is f of 3, so my calculation is correct, at least up to this point. Okay? And if anyone wants to know, why do we care about, strange numbers like this, you can read the rest of the wiki page. I'm not going to read it in this class, but apparently it has some sort of significance. Okay?
So it's whatever number before that plus that number, and it gets the next number under that same thing?
Yeah, it is recursive. Okay? So now the question is, how do I write an algorithm to do exactly that? Okay, let's go ahead and take a look at the algorithm. Define sub f, okay, because I don't want to spell out Fibonacci the whole time. It makes the line really, really long, so I don't want to do it that way. The first thing, is to specify a single parameter. In this case, we specify the parameter n. And then you have to check to see if n is 0, because if n does equal to 0, you return 0, because the f0 is 0. Otherwise, you check whether n is 1, because f of 1 is 1. If that is not the case, then you have to use the recursive definition. Then you say return invoke Fibonacci with n minus 1 going to n plus invoke Fibonacci n minus 2 going to n, like that. And if and define sub. Obviously, indentation can be a little bit helpful here. that. And my program just want to find out what is the Fibonacci number of, what was it, 3? Okay. Like that. Do you think we have talked about all the pieces that we need to get this done? I think so too. Okay. This is going to take some time, but it does not involve any new concept that we have not talked about. Okay, that's the most important part is we should be able to do it. It will take some time, but we have all the pieces in place already to talk about this. So I will just call this one by its name, Fibonacci. I like my new compact flash card. It works. It works. Okay. All right. We need comments in this case for sure because we have conditional statements. We have line number, but we don't have any global variables, so the precondition is trivial. We go to line 11 first, and we need to invoke f in this case. We need return info because Fibonacci or subroutine f returns a value. Whenever you invoke a subroutine that returns a value, you have to switch to return info. Okay? Because we have to go back to the same line again. In this case, the return info will specify we go back to line 11, but what is left to do when I return is just to print out the value that the Fibonacci subroutine is returning. Are we doing okay so far with this? We're just replacing the invoke part with a single question mark. Then we have to specify the parameter, which is n. N is passed by value. In this case, it has a value of 3. Are we doing okay so far with the first invocation of subroutine f? Then we go into the subroutine starting on line 3, which starts with a comparison. N equals to 0 is false. That means we have to go to line 5 to check the second condition of the multi-branch conditional statement. N equals to 1 is false too. That means we have to go to line 8. Line 8 looks kind of nasty because it is a return statement, but in order to know what I'm supposed to return, I have to invoke f twice. Because we are reading from left to right, I take care of the left-hand side first. So this means I'm invoking f with n minus 1 to specify n. That means I also have to allocate one additional column for return info. This time we are returning back to line 8. But by the time I return to line 8, the first invoke will now be replaced by a single value. But I do have a second invoke to take care of when I come back, but I'll deal with it later. I'm not even worried about that at this point. Are we doing okay so far with the second invocation of subroutine f? Not quite done yet because it has a parameter n. What should I put here? Okay. This n is 3. 3 minus 1 is 2. So the new parameter has a value of 2. Very good. Then we go back to the beginning of subroutine f again, because every time you invoke a subroutine, you always start from the first line in the subroutine, even in the case of a recursion. So in this case, we start with line 3 again. N is 2 at this point. N equals to 0 is false. We go to line 5. N equals 1 is false. We go to line 8. Okay. Now, if you want to be lazy, you can copy and paste. But when you copy and paste, you have to be careful because one of the columns needs to be modified because n is now 1. Are we doing okay? Yes? Sort of? Yep.
Why don't you just pull it out and invoke and
Well, this way we can actually see a little bit better.
why did invoke a f n minus 2 a question mark now?
Say again?
Why does it, where it says return question mark plus invoke of f and
Because
minus
we are taking care of the left-hand side of the addition.
So we haven't called the second invoke.
We have not called the second one yet. We're only taking care of the left-hand side. Okay. Are we doing okay so far with this? Yes? Okay. Because if we need to stop, this is a good time to stop. Yep.
Could you? No, you couldn't.
It
Because
resembles
a lot of-
it resembles exactly this structure here.
Oh,
I'm
I
trying
know
to-
that, but
Mhm.
I was wondering in my dull little mind why you couldn't do the F
Other one
and
first?
2 first, and it goes back to the law of parentheses,
Because we have to follow the mechanism and
Right.
read from left to right. That's
which is
basically
the law of parentheses.
right. Yep. Go ahead.
So we keep invoking the n minus 1 until it gets to 0 or 1, and then we stop invoking, then we do the n minus 2.
Well, we'll find out. Go ahead. We'll figure this out. It's using the same order as we have done it here on the whiteboard, except in this case, we are trying to express it as a trace instead of just saying, oh, okay, F2 equals so on and so forth. Now this is another invocation, which means we are now back to line 3. Back to line 3, we have to compare n to 0. N equals to 0 is false. Then we go to line 5. N equals to 1 is true this time, because n, or column H, does equal to 1. Now when line 5 is true, we go to line 6. Line 6 is return 1. Now here is the confusing part. The confusing part is because I am on line 6, which is a return statement. The return info cell is also a return statement. Don't let that bother you. Okay? There's absolutely nothing wrong with this. It does not change what we do when we execute a return statement. In other words, whatever I have in return info can be gibberish. Okay? As far as I'm concerned, as a subroutine, I don't even care what is in return info cell. The only part that I care is, does it have a question mark? If it has a single question mark, I'm happy, because that's all I'm going to do, is to replace the question mark with the value that I'm returning. Are we doing okay so far? Because you have to separate the execution of the return statement from whatever you are processing as you execute the return statement. So in this case, we do exactly the same thing as we have done before. We copy and paste, change the question mark to the value I'm returning, and I'm done as a subroutine. Okay? I'm not executing line 8 at this point. After line 6, we get out of the conditional statement. We get to the end of the subroutine, which is on line 10. At the end of a subroutine, we have not changed the behavior of n-defined sub for some time now. We just deallocate whatever columns we have allocated at this point, and then we go back to wherever return info tells me to go back to. Return info in this case tells me to go back to line 8, and line 8 now looks like this. Can I execute this return statement? No, because we have one more invoke to take care of. Okay? So that means I have to switch back to column E and column F to execute line 8. But line 8 is saying, oh, we still have to invoke something else, but this time you have to remember n has a value of 2. So the next time when we invoke, we have to specify return info, but this time line 8 looks like return 1 plus question mark, because we are now taking care of the second invoke.